In these last three sections of Chapter 4, we will be talking about representations and shapes of covalent molecules. Before we talk about a whole molecule, let's talk about how we can represent individual atoms. A Lewis dot symbol is a way to represent valence electrons in an atom. The valence electrons are the important ones because they are involved in bonding. Remember, for the main group elements, the number of valence electrons equals the group number on the periodic table. To write a Lewis dot symbol, first write the symbol for the element and then place dots around it to represent the valence electrons. The dots should go in separate quadrants first, up, down, left, or right. Once all four quadrants have one dot, a second dot may be placed in each quadrant if necessary. We only put the dots in separate quadrants for individual atoms. When we get to Lewis structures of molecules, the dots will almost always be paired. It doesn't matter which quadrants you use. For example, aluminum could have the dots as shown, or they could be in the top, right, and bottom quadrants, or they can be in the right, bottom, and left quadrants. Each Lewis dot symbol would have the number of dots equal to the number of valence electrons for that particular atom. What is the Lewis dot symbol for a sodium atom? Is it A, Ne with 4 pairs of dots, B, S with 2 pairs of dots and 2 dots, C, Na with 1 dot, or D, Na with no dots? The correct answer is C, Na with 1 dot. The 1 dot represents the valence electron in sodium. Remember, sodium is in group 1A, so it has 1 valence electron. Remember your electron configurations. Sodium's electron configuration has a neon noble gas core and then 3s1. That final electron is its valence electron because it is in the outermost shell. We can also draw Lewis dot symbols of ions. Cations like the sodium ion have lost electrons. To draw their Lewis dot symbol, we would take the symbol for the neutral atom and remove electrons. Sodium loses its 1 valence electron, so we take the dot away, and we are left with a naked symbol for sodium. We need to include the charge, however, because it is an ion. So the Lewis symbol for the sodium ion is Na+. The calcium atom loses both of its valence electrons when it makes the calcium ion. Both dots go away, we add the charge, and get Ca2+ for its Lewis dot symbol. Anions like chlorine have gained electrons. To draw their Lewis dot symbol, we would take the symbol for the neutral atom and add electrons. Chlorine gains 1 electron, so we draw 1 more dot into the empty hole in its right quadrant that has space for 1 more electron. The chloride ion ends up with 8 dots around it. Just like with the cations, we need to include the charge, but this time we need to surround the ion in brackets first. The brackets tell us that the charge is just somewhere in the ion. It is not any one particular electron, but could be any of them. Similarly, sulfur has 2 empty spots and gains 2 electrons when it becomes an anion. We draw in those 2 dots, enclose it in brackets, and add the -2 charge. To make Lewis structures of ionic compounds, we basically just have to slide the Lewis dot symbols of the ions together. For example, sodium loses its valence electron and chlorine gains an electron. So we get the sodium ion with no dots and a +1 charge, and we get the chloride with 8 dots, brackets, and a -1 charge. The red dot in this figure is being transferred from the sodium to the chlorine. Once you draw the Lewis dot symbols of the ions, just smoosh them together to represent sodium chloride. Similarly, magnesium loses 2 dots, and oxygen gains 2 dots when we draw the symbols for those ions. Then we can just draw the ions next to each other. Here's where it gets a little trickier. Calcium has 2 electrons to lose, but fluorine only has 1 hole to fill. Therefore, we need 2 fluorine atoms to accept the 2 electrons being lost by the calcium. The calcium loses 2 dots, and the 2 fluorines each gain 1 dot. When we put the ions together in the symbol for the ionic compound, we can use a subscript on the fluoride ion to represent that there are 2 of them for each calcium ion.